Hi, in this video we will learn about the inverse sine function. This is inverse function of the trigonometric function sine. We will do examples, we study basic properties. Exactly same tricks can be applied to the other trigonometric functions, but we won't do those other ones in separate videos. In another video I will just go through all the inverse trig functions in very generality. But for sine, we will do everything with details and examples. Okay, so let's see what we have. We want to do something. We want to find an inverse for the trigonometric function sine x. Very nice, because well, if you find sine inverse of such function, it will be useful. You will find more interesting identities and so on. But right away, there is this issue that, well, inverse function exists only for one-to-one functions. Sine x is not one-to-one. Why is that so? Because, see, okay, I can sketch the graph of sine x. Well, it goes something like this, then goes down like, and then repeats itself. It's actually not only not one-to-one, but also the worst kind of not one-to-one, because, well, it is periodic. It repeats itself infinitely many times. And what happens is that if you draw a horizontal line, any horizontal line between -1 and 1, you will see that it intersects the graph of the function infinitely many times. So it fails the horizontal line test. So what should we do then? Then there is a very nice solution for this. It says, well, although the whole function is not one-to-one, but we can just focus on a small piece of domain on an interval on which the function is one-to-one. So the solution is restrict on an interval on which sine is 1-to-1. Well, it in practice means that while you see this line, for example, this line intersects with the graph here, and there's a distance between different points. But if you look at this piece, only the piece between -pi/2 and pi/2, wherever you draw any horizontal line, at most it will intersect once. So this means that, well, forget the other pieces. Let me just erase this horizontal line. Forget the other ones. Just consider the function on this. If you consider on this the sine x, this is going to be 1-to-1. Well, and then you can find the inverse of that, inverse function of that function. So the standard piece that we do here is that sine is 1-to-1 on the interval -pi/2 and pi/2. And since it is invertible, it is 1-to-1, we can have its inverse. So definition comes here now. The inverse function of sine x, well, sine x doesn't have inverse function, but we are talking about sine x restricted on this domain, is a function where denoted by, so let's see what is the notation denoted by. The notation is very natural thing. So I'm looking for the inverse function of sine. So maybe sine inverse of x. And well, some people would say better convention would be to say arc sine. Sine gets an angle, returns ratio. The inverse function will eat an angle. It will give us, sorry, the other way. The sine inverse will eat a ratio, a number, and will give us an angle. So that's why some people choose to use arc sine x as the inverse function. Which has the domain the domain of inverse function would be the range of the function. The range of function here you can see is from -1 to 1. So that is which has domain from -1 to 1 and is defined by, so if you're looking for sine inverse of a number, it's going to be an angle such that sine of that angle is equal to x. And we have to be careful that angle can only be between -pi/2 and pi/2. That is the definition. So basically reversing what sine does. Example, let's see some examples. Well, what is sine inverse of √3/2? How about sine inverse of -1/2? And let me just write one more. Sine inverse of 1. Well, okay, so we are looking for an angle on the interval -pi/2 and pi/2 whose sine is √3/2. Sine of pi/3 has all those properties. First of all, its sine is √3/2 and it is an angle in the interval -pi/2 and pi/2. So this will give us pi/3. How about sine inverse of -1/2? So we are looking for an angle whose sine is -1/2 and it belongs to the interval -pi/2 and pi/2. You see there are infinitely many angles whose sine is -1/2, but we are only choosing the one which is in this interval. In this case, well, this is pi/6 and it satisfies both conditions that we have there. And sine inverse of 1 is, well, pi/2. So we are reading the table of values for sine and cosine the other way around. Okay, so this tells me that, okay, so first thing to see is that, remark, we have the sine inverse function property. So inverse function property implies that if you have sine inverse of a number, this will give you an angle, and then you take the sine of that. This will be the same number that you started with. Sine inverse of sine of an angle Well, you have to be very careful. This is not in general equal to theta. We will see in examples why. It sometimes you have to be careful. You have to bring it down to this interval. Otherwise, this is not going to be true. So only when theta is there. The above, this one you can use, doesn't matter what is x, it will give you the same thing. But for this one, well, here, everything in the domain means everything between -1 and 1. So, for example, again, evaluate. For example, evaluate what? First one is sine inverse of 2/3. Another one would be, how about sine inverse of sine of I have the angle here of 5π/6. And well, what about we do something like cosine of sine inverse of 1/3? Or for example, what about sine of 2 sine inverse of 1/4, and so on. So you can ask these kind of questions. Well, first thing is that sine of sine inverse always gives you back the number. That is always true. But in the second example, you notice that sine inverse of sine of 5π/6. If I just write, let me just for a second write, this is 5π/6. I'm making a very, very bad mistake, because you see sine inverse always gives us an angle between -π/2 and π/2. But 5π/6 is bigger than π/2. Hey, do you see it? And this cannot be true. Well, why it's not true? Because you see, this is not always true. This only is true if theta is an angle between -π/2 and π/2. Here what we have is an angle which is somewhere here. This angle. But what we know is that, well, I can replace that with the angle of this guy here, which is π/6. These are going to have the same sign. Well, then I can rewrite this thing as sine of 5π/6 is the same thing as sine of π/6. And now we are in a good domain. π/6 is the number between -π/2 and pi, and then this is π/6. And you see that this was not true, but what was true is this one. How about cosine of sine inverse of 1/3? Let me put it a little bit higher. Well, here there's no obvious relation between cosine and sine inverse. I mean, we don't have any formula like that for cosine of sine inverse. But what you can notice is that, first of all, sine inverse of 1/3, let's call this one theta. This is an angle whose sine is 1/3. So it means that its sine is positive. And we already know that this is either in the fourth quadrant or the first quadrant. So this tells us either here or here. Here sine is negative. That means that our theta is going to be somewhere here. That's for sure. Now, what else we know? We know that its sine is 1/3. Well, use the tricks we always use. Form this triangle. Well, sine of theta, if you have a triangle, will be always adjacent over hypotenuse. So it will be 1/3. Well, that's one possible triangle for this. And then using the Pythagorean theorem, you get 9 minus 1, which is √8. So then, what you can see that the cosine of that angle, which is sine inverse of 1/3, is equal to √8 adjacent over hypotenuse. This you can simplify and write, well, not simplify, just write it as this one. How about this one? Sine of 2 sine inverse of 1/4. Well, sine inverse is always, they cancel each other. So this is true. But now we have a number 2 here. That's the big issue for us. Well, this is an angle, yes. So you can use double angle formula and simplify this. You can write this as 2 sine of sine inverse 1/4 times cosine sine inverse 1/4. And now you see that this is sine of sine inverse. That will give us 1/4. Cosine of sine inverse, however, you can again form an angle. Again, this angle is going to be in the first quadrant somewhere here. And it has 1/4. Then we get √15 here. So the cosine of that would be adjacent √15 over hypotenuse. And all together would give us √15/8. And well, tricks like this, so you can deal with tan of sine inverse and so on. But you have to be always careful about the sine. Is it going to be positive, negative, or what kind of numbers that those trig functions will get. Well, 2 more things. One is the domain and range. So we already know, remark, it's obvious that domain of sine inverse function is, well, the range of sine, which is -1, 1. So you can plug in only, or input only numbers between -1 and 1. And the range of sine inverse is the restricted domain of sine, which is -π/2 and π/2. Well, especially the first one, you may be able to combine that and find domain of more general function. For example, find domain of e to the power x. The function I have is domain of f of x is sine inverse of e to the power x minus 3. Well, what we know is that sine inverse only accept numbers which are between -1 and 1. So that means that we are allowed to use x's such that e to the power x minus 3 is between -1 and 1. Well, you can add 3 to all sides, so we get 4 and 2. So we are allowed only find the numbers, so basically domain of x or of f is equal all x's on real numbers such that this happens. But what kind of numbers are those ones? Let's just have a look at the graph of e to the power x for a second. So e to the power x, something like this. And now we are just picking the parts of this guy, which is between 2 and 4. What kind of x's we will have? Well, the x of such a thing will be exactly between the number whose e to the power x is equal to 2 and another number, let me put x naught, and e to the power x1 would be 4. Yes, because this is the interval which will be sent to that interval. So it means that we are dealing with all x's which is between x1 and x0. But we already know how to solve these guys. This is just very exponential, a very easy exponential equation. Find ln of both sides. It will give you x0 is ln 2, and from this you get x1 is ln 4. What we learned is that to have this thing, domain of f is all x's on real lines such that x is between ln 2 and ln 4. And very last piece is that what is the domain, what is the graph? Remark again, the graph of sine inverse x. Well, sine inverse is the inverse function of sine when you're restricted on the domain negative pi over 2 and pi over 2. So we saw that, well, this domain, this graph on this domain is something like that. Now we want to find the inverse, so we have to find the reflection of that with respect to the y equals to x. So it will give us something. I'll try to it is something like, that's with a little bit, my graphs are not very good, but this will be what we have there. So if I delete these guys here, okay, almost, yeah, something which goes here, which goes from -1 to 1, the domain is there, and the range is negative pi over 2 and pi over 2. So this was an introduction for inverse sine function. The trick that we use, restricting the function, trig function sine to a smaller domain, is a trick that we will use for other trigonometric functions and define the inverse of those trigonometric functions.